Hi, and welcome back to Algebra 1. Our goal for today is to continue working with solving our equations and inequalities, and more specifically, a problem that is even bigger and more complex than a multi-step problem where we have a variable or letter on both sides of our equal sign or both sides of our inequality symbol to start. So our steps for today, how to go about solving when we start with variables on both sides. Take a second here, hit your pause if you need to, fill in your blanks. Now for these problems where you have a variable on both sides of your equal sign, you still want to start the same exact way that you would start with your multi-step problems. On each side of your equal sign, you want to go through your steps of simplifying. Is there a place where I can distribute or expand using the distributive property? And are there like terms we can combine to simplify? Once you do that, you're going to have a simplified expression on each side of your equal sign or on each side of your equation. From there, you want to try to condense or get all your variables into one location. And that's going to require you doing an inverse operation with one of your terms that has a variable, which is the new thing for today. Once you take your variable and get it all on either in front of the equal sign or maybe behind the equal sign, there's two special cases that could occur based off of the fact that maybe your variable terms will cancel or eliminate when you move them to the same side of the equal sign. So special case number one is when I go to move my variable all on one side and all the terms that have a variable get removed or canceled. And I end up with what's called a true statement where I have a number equals a number. So for example, something that looks like this. I have a 10 equals 10. Right? That's a true statement. 10 does equal 10. Then that's a special case where we would say that in this case there's an infinite amount of solutions, and we describe that with describing it as all real numbers are solutions. So all real solutions. Now scenario number two is my variables, when I move them to get them all on the same side, all cancel, and I end up with a false statement. So something that looks like this. Number and does not equal another number, right? Where I have something that is false, right? 10 does not equal 5, so I would have to slash my equal sign there, right? That reads as does not equal to or is not equal to. When I have a false statement, then no real numbers would work for our variable in that particular problem, so we'd have to describe the final answer is the actual statement, no real solutions. So let's look at some examples. Number one, 7n minus 5 equals 10n plus 13. Now this is as basic or as simple as it's going to get when we have a variable on both sides, because all the simplifying has already been done here. Right? There's no place to distribute and there are no like terms. So once we get here and both sides of our equal sign are in their most basic simplified version, our goal is to get our n terms all on one side. Now, normally students like to take whatever's behind the equal sign and move it to in front of the equal sign. So that's option one. I could take the 10n and move it by subtracting a 10n from both sides. However, I could also take this 7n and move it back behind the equal sign by subtracting a 7n from both sides. But I have to show an inverse operation where I either move the 7n over onto the side with the 10n or the 10n over to the side with the 7n. Since most students like to have the variable in front of the equal sign, I'm going to move my 10n term with an inverse operation of subtracting 10n from both sides. Now, my suggestion to you, since we're going to be subtracting 10n from both sides, is when I do my subtract 10n in front of my equal sign, I'm going to put it right here next to my term that is the 7n, because those are like terms that are going to be able to go together. Same thing over here, I have 10n, I'm going to subtract 10n from it, and then I still have this plus 13. All right, behind our equal sign, these two terms are opposite, so we'll eliminate, they'll cancel. And all we'll have left back here is a 13. All right, in front of our equal sign, 7n minus 10n, those are like terms. We can put those together. So 7n minus 10n would give us a negative 3n, and we still have a subtract 5. And now once we get here where our variables are all in one location, we're going to either be back to a one-step or a two-step equation. In this case, we have multiply and we have subtract, so this is a two-step equation. I got to cover up my n term. I got to get rid of a subtract 5 by adding 5 to both sides. Negative 3n minus 5 plus 5 equals our 13 plus 5. All right, our 5s will cancel on the one side. We still have our negative 3n. 13 plus 5 more would just give us a value of 18. From here, we need to remove our multiplying by negative 3. So our next step would be 5 both sides by negative 3. All right, cancel on the one side, bring down our n equals 18 divided by negative 3 would give us a negative 6. Good final value of n. And not a special case here because we did end up with an n equaling an individual value. All right, number 2. All right, a little bit bigger, a little bit more complex here because it's not basic yet. All right, number 2. All right, a little bit bigger, a little bit more complex here because the problem's not in its most basic simplified version yet. So in front of our equal sign over here, we have an 8y plus 4. There's no place to distribute, and there are no like terms. So that side's done. It's in its most basic simplified version. However, behind our equal sign, we have 11y negative or subtract 10 minus 7. We can take these two like terms and combine them. So we want to do that first. We want to get each side in their most basic simplified version first. So 8y plus 4 equals our 11y. And then negative 10 minus 7 more would just give us a negative 17. Be careful, this sign goes with this number when you combine your like terms. All right, now we're back to both sides being as basic or simplified as possible. And so from here, we want to get our y terms all in the same locations. I have two options. I can take this 8y and bring it over to that side with the 11y by subtracting an 8y on both sides. Or I could take this 11y and bring it over to the front side by subtracting 11y from both sides. Since most students like their variable in front of the equal sign, again, that's what I'm going to do. So we have 8y, subtracting the 11y, and we still have our plus 4. Over here on our right side, we have 11y minus 11y minus 17. All right, these are opposites, 11y and negative 11y, so they'll cancel, leaving us with just a negative 17 over here. In front of our equal sign, 8y minus 11y are like terms. They can go together, giving us a negative 3y plus 4. All right, at this point, if we still have a variable remaining in the problem, we'll either have a one-step or a two-step equation that we need to solve from there. So in this case, again, we have a multiply and add, which is a two-step problem from here. So we're going to start by subtracting, and the amount is a 4 from both sides. All right, cancel on the one side, bring down our negative 3y. Negative 17 minus 4 would just give us a negative 21. All right, from there, we need to get rid of our multiply by 3 by dividing each side by the negative 3. Resulting in a y is equal to a negative divided by negative here would end up giving us a positive 7. So not a special case here. We ended up with one solution for y being the value of 7. All right, number 3, we have x minus 4 minus 3x equals a negative 2x minus 3 minus 1. Again, this problem is a little bit bigger and more complex because it's not already in its most simplified basic version. So you want to do any simplifying in front of your equal sign and any simplifying behind your equal sign before you start worrying about getting all of your x terms in the same location. From here, in front of your equal sign, we have a 1x and a minus 3x. Those are like terms. They can go together. So 1x minus 3x will give us a negative 2x. And we still have a subtract 4. And now that side would be in its most basic simplified version. All right, behind our equal sign, we have a minus 3 or negative 3, minus 1. Those are like terms that could also go together. So negative 3 minus 1 will give us a minus 4. All right, now that we have each side in their most basic simplified version, we want to get our x terms all in the same location. So I can take this negative 2x and take it to the back side of the problem by adding a 2x to both sides. Or I can take this negative 2x and bring it to the front by adding a 2x to both sides. All right, since most of us want the x's in the front, I'm going to go ahead and take the back one and move to the front. Negative 2x, we're going to add 2x. We still have our subtract 4. Back here, again, we have a negative 2x. We're going to add 2x, and we still have our minus 4. Now, here's where you need to be careful. These terms over here behind our equal sign are opposites. They eliminate, leaving us with a negative 4. In the front, these are also opposites, which would eliminate, leaving us with a negative 4. And now we can see that this one is a special case because all of our x terms canceled or eliminated while we moved them to the same location. So from here, we need to look at our statement and see if it's true or false. If this statement now with our equal sign is true, then any real number can be substituted in for x and result in a true statement. So every real number is a solution. If this statement here is a false statement, then we'd have two things to do. We'd want to slash our equal sign to show that that's not true or not equal to, and no real solution would be our final answer. So since negative 4 does equal negative 4, our final answer is actually that all real numbers are solutions. So all real solutions. Please do not just leave it as negative 4 equals negative 4, right? You need to identify what works for the value of x in this case, which is any real number. All right, number 4. All right, 3 minus 5b plus 2b equals negative 2 minus 2 times 1 minus 1b. All right, this one's a little bit different because there's definitely simplifying to do, and it also has a distribute or expand simplified to do. So this side in front of our equal sign does not have any place to expand or distribute, but behind our equal sign, we have this negative 2 that has to get cheered to 1 and negative 1b. All right, so we want to start with the distribute. So in front of our equal sign, since there's no place to distribute, we're leaving that as 3 minus 5b plus 2b. We'll get back to that in a second. Over here, we have a negative 2, and then we have to expand using the distributive property by taking the negative 2 and multiply it with the 1 minus 1b. The negative 2 times 1 would give us another negative 2 here, and negative 2 times a negative 1b would actually give us a plus 2b. All right, from here, we want to combine like terms. In front of our equal sign, we have a negative 5b and a 2b that can go together. So negative 5b plus 2b would give us a negative 3b. And then we still have a plus 3. Now, I chose to put the negative 3b in front, but you could also write 3 minus 3b there. It would mean the same thing. All right, back here, negative 2 minus 2 can go together, so we'll end up with 2b minus 4. Again, I could have negative 4 plus 2b. Perfectly fine. All right, from here, we want to get b's in the same location. So I have two options. I can take this negative 3b and move it by adding a 3b to both sides, or I can take this 2b and move it by subtracting a 2b from both sides. Since most of us like our b or variable in front of the equal sign, that's what I'm going to do by subtracting a 2b from both sides. All right, negative 3b minus 2b would just give us a negative 5b. We still have our plus 3. And then 2b minus 2b are opposites. Those will eliminate or cancel, leaving us just with our negative 4. All right, since there's still a b variable in our problem, this is not a special case. And from here on out, we'll either have a one-step or two-step equation that we can solve. In this case, it's a two-step because we have a multiply and an add. So we're going to start by subtracting, and the amount would be a 3 from both sides. Working through PEMDAS backwards. All right, eliminate our 3's. We'll have negative 5b equals, and then negative 4 minus 3 would just give us a new amount of negative 7. All right, from there, we want to get rid of a multiply by negative 5. So we're going to divide both sides by negative 5. Be careful here with your signs. A negative divided by negative is going to result in a positive. In this case, a positive 1 2/5. Or you could say 1.4. Either would be perfectly fine. But you need to get the exact answer here of 2/5 or 0.4. Don't round anything off. All right, number 5. A little bit different because we have some distributing here and we have some fractions in our original problem. So we want to solve for the variable d when we're told 1/8 times 3d minus 2 equals 1/4 times d plus 5. All right, both sides have a place where we can expand using the distributive property, so we want to start there first. So 1/8 times 3d will give us 3/8 d. 1/8 times negative 2. We're sharing both things in here. We give us a minus 2/8 or 1/4, however you want to write it. All right, from here we want to distribute on our other side the 1/4 to the d plus 5. So 1/4 times d would give us a 1/4 d. And then 1/4 times 5 would give us 5/4 would be the improper version, or 1 1/4 would be the simplified mixed number. Both perfectly fine ways to write our value there. All right, there are no like terms here, so now we're ready to move our d terms all to one location. I'm going to continue to take this back one and move it to the front, since most of us want that d in the front portion of the equation. So we need to get rid of a 1/4 d by subtracting 1/4 d from both sides. So we have 3/8 d. We're going to subtract 1/4 d from it. We still have our minus 1/4 here. All right, what we do to one side, we got to do the other. So over here we have 1/4 d. We're going to subtract our 1/4 d from it. And we still have our term back here of 1 1/4. All right, behind our equal sign, these are opposites. These are going to eliminate. We're left with 1 1/4. All right, in front of our equal sign, a 3/8 minus 1/4, which is 2/8, would just give us 1/8 d, and we still have our minus 1/4. All right, at this point, since d is still in our equation, it's not a special case, and we're going to end up with one solution. And in this case, we have a two-step equation to solve from here down. And we need to get rid of a times and a subtract. So we need to start with the subtraction by adding a 1/4 to both sides. All right, 1 1/4 plus another 4th would end up giving us a 1 1/2. All right, we're not quite done. We now need to remove, this is a multiply here, a 1/8 times our variable d. So it's going to take an inverse operation here of dividing by 1/8 on both sides. 1/8 d divided by 1/8 equals our 1 1/2 divided by 1/8. All right, cancel, bring down our variable d, do our divide on the other side. 1 1/2 divided by 1/8 will give us a value here of 12. The final value for d. Not a special case, because when we got done solving, we actually got a value for our variable d. All right, last one. 7 times 2x plus 3 equals a 21 plus 14x. All right, we have a place to expand using our distributive property. We want to start there first. 7 times 2x and 7 times 3. 7 times 2x would give us a 14x. 7 times 3 would give us a 21. And over here we have a 21 plus 14x. All right, there's no other simplifying that can take place here, so we're going to get all our x terms in the same location. Again, most of us want our x in front of the equal sign, so I'm going to go ahead and move this plus 14x by subtracting a 14x from both sides. We have 14x minus 14x plus 21 equals our 21 plus 14x minus 14x. All right, these are identical back here, so they're going to eliminate, leaving us with just a 21. Up here, these are also identical, so they're going to eliminate, leaving us just with a 21. Since there's no variable left, this is a special case, and we have to look and say, does every real number work because I have a true statement, or does no real number work because it's a false statement? since 21 does equal 21, that means any real number could be put into this problem for x and it would yield a solution or a correct statement. So all real numbers here are solutions. So all real solutions would be our final answer. Please do not just leave it as 21 equals 21, because we need to express what the solutions are for the variable x. All right, I hope that helps you attack your work for today. See you guys later.